Okay, good morning, one and all, and welcome, Mr. Ashok Saraf sir. Uh, as part of the Institution Innovation Council and as jointly organized with the Department of Electrical Engineering, today we are organizing this expert session on the problem solving and ideation workshop. So I would like to introduce the great and eminent personality here, which is going to deliver this and going to take charge for another 1.5 hour or 1 hour, Mr. Ashok Saraf sir. So I would like to a little bit introduction about him. So Saraf sir has completed his BTech from the IIT Bombay in 1973 from the electrical stream. Also, he had completed his diploma of Philips International Institute from the Holland in 1974. Also, he had a master's in electronic engineering from again from the Holland in 1975. So he had various expertise, and also he has served as a design engineer, product manager, technical consultant, engagement manager, then senior vice president. So at various national as well as international companies. So, sir has various honors with him as he is currently working as a trustee for the Science and Technology Park, University of Pune, and the chairman of Pune Electronics Cooperative Society Limited, Pune. So today, sir is going to brief us about the problem solving and ideation workshop. So first of all, on behalf of Swaris College of Engineering, Pandharpur, and the Department of Electrical Engineering, I welcome you for this session, sir. And I would like to request you to please take a charge for this session and please continue. Over to you, sir.
Thank you very much, Anil sir. Good morning, everybody. Am I audible?
Yeah, you are totally audible, sir.
Yeah, good morning. First of all, welcome to this workshop where we are going to look at how do we look at problems, and then how do we think, how do we ideate. The ideate means how to generate idea, kalpana. How do you construct a solution for solving that problem and then present it so that we can implement it, or we can even evaluate whether the idea is going to work or it is not going to work. And how do we cross-check these ideas by sharing the ideas with each other. So this is a very important part of the process of engineering. We learn engineering starting with drawings and formula, rules, then mathematics. We learn various patterns of design, various things, various systems, circuits, various items like motor, materials, semiconductor, generating stations, wires, grid. These are all things, these are all systems which are created by our forefathers, electrical engineers. Electrical engineering is not a very old discipline, though it is one of the oldest. Still, it is just a couple of 100 years back. Okay, but it has evolved and it is continuing to evolve. What is this process by which things evolve? How do things change? What was the work that Benjamin Franklin was doing when he was curious to understand what exactly happens in the lightning? What was Coulomb doing when he was doing some experiments with charges? What was Ampere doing when he was experimenting with some phenomena? So there are two aspects. One is curiosity. Then the new era started when Edison started working on problems. The problem he looked at is, for getting the illumination, for getting the light, people had to burn the oil. Even today in India, in some areas where there is no electricity, we depend on the oil lamps. So something burning gives light. Edison had seen that something going very hot also gives a light. So, and he also saw that if you pass a current, electric current, then the wire, some materials get hot. So by connecting the two things together. So here, please observe now, this is very peculiar to understand. He was observing, at the same time, he was thinking to solve some problem, solving a problem to satisfy certain need or want or demand. So he saw that there was there were gas lamps before that, before the electric lamps came. So after kerosene lamps, when the gas was discovered, that if you pressurize the kerosene, you might have seen gas batti in villages even today. In some barat and all, they would carry gas battis, Petromax they call it. So those were the lamps. Even in railway stations, I remember the lamps were all gas lamps. Then the electric lamps came. So Edison wanted to solve a problem of illumination and wanted to use electricity. Henry, माझं ऐकू येते ना, तुम्ही सगळ्यांनी माईक बंद ठेवा प्लीज.
All other are requested to mute yourself. Savan sir, please, from your side also, you just mute everyone except Saraf sir, yourself, and myself.
Okay, sir.
Yeah, sir, please continue.
Yeah, thank you. So he was trying to solve a problem and he was trying to apply his observation.
Aniket Padawale. Aniket Padawale.
Okay. So he was trying to apply his observations. Out of observation, what happens in our mind when the child is observing? What happens? Child learns. The neural networks in the brain records relationship, pictures, names, language, words. Then what happens if something is happening, that is causality, because of suppose the water is on the floor and then somebody falls because the food slips over the water, the child learns. So child continues to actually keep on doing various experiments by interacting, by running around, by climbing, by jumping, by talking, by listening, by asking questions. And you all are doing it. Even today you are doing it. You are listening to me, you are thinking while you are listening, you are reading, you are trying out different things, you are learning programming, you are trying out programs. And if you keep on doing this thing, it can be a lifelong process. But what happens with this process? A knowledge happens in our brain. We become knowledgeable. We know, we understand. There is a difference between people who learn and people who don't learn. If you don't have knowledge, you don't understand many situations, and therefore you cannot change or you cannot control them. You are subjected to them. If there is a drought, there is no water, and if you don't understand things about the water, how water behaves, how water is stored, how water can be stored in a dam, then you can use it when there is no rain. So when that knowledge comes, you can solve the problems. You can create, you can make a change, and that change is called solution. So constructing a dam for stopping the river, which is otherwise wasting that water into the sea, and storing it between the hills to make a dam, is a civil engineering solution for water problem. So Edison was trying to solve the illumination problem by using electricity, and the rest is history. You have seen. So this process continues even today. In our own lifetime, you must have observed the yellow lamps of tungsten filaments, which was getting hot, and they were in vacuum or in the inert gas in the glass bulb. So the whole thing had to be carefully handled. It was consuming large power. Out of say 60-watt bulb, Out of 60 watt, hardly a couple of watts of light was coming out. Rest was all wasted in the heat. So it was inefficient. Then came the compact fluorescent lamps, which would generate plasma, and then plasma would be hitting the fluorescent powder on the glass in the inside of the bulb, and then that would emit light by fluorescence. It will take the energy of electrons and then emit uh, photons. So this was discovered as a chemical process. Electronic was electrical was helpful for generating plasma. So it was study of materials, electricity, electric fields, vacuum, all those things put together came out the solution of compact fluorescent lamp. But then somebody tried to do that process in solid state in Japan in company called Nichia, and he discovered that if he has a solid state uh, material of such type that it emits ultraviolet, and then if he puts phosphor, which is otherwise in the compact fluorescent lamp, if he puts that on the uh, uh, semiconductor, then the ultraviolet can be converted into a light, and that is how the white light was born. So essentially, it is ultraviolet LED which is converted into visible light. So the whole world is now changing. You are seeing, you are witness of that. All the lamps are becoming LED lamps. So what light you used to get with a 100-watt bulb, today you can get it with a 9-watt LED bulb. So there is tremendous saving. So this is something peculiar of a solution. A solution is revolutionary. If it not only solves problem, but it solves problem by making it better, cheaper, and faster. Suppose there is a drilling action. Can you hear me? There is some water falling behind me. So is there a noise, or you can hear me well?
No, sir. It is perfectly well, sir.
Okay. Anyway, the water will finish. Somebody is trying to solve the problem of water leakage on the roof. So he was testing that by putting the water on the terrace. And then now he has identified the location. So this, coming back to our story. So this is how the problems are solved, and some solutions are revolutionary. But it doesn't mean that everybody has to come out with a revolutionary solution. Edison had to struggle for a number of years and test many solutions before he could come to a workable solution. He would use a carbon filament, and then it would just turn into ashes. It will give a light for some time. Now, putting a filament of a metal in vacuum and sealing it so that it doesn't get oxidized, though it sounds very simple, to discover that he took a lot of efforts, a lot of experiments, and then he had to construct those things. He had to test those things with the clear aim, target. That is, I want to make something which will produce light and which will last very long. It will be cheap, so that everybody can use it. So these are the three things: better, cheaper, and quicker. Those should drive us for generating idea. Then the knowledge and the experience that we have gained by observation, like a child. And if you continue your childhood processes of learning, then you will continue learning. So whatever you have learned, if you use that for finding the solution, then what happens? The knowledge gets applied and you get into solution, or you get ideas. So it is a mixture of observation, knowledge, and thinking about the problem. What if I do this? What if we do that? What if this happens? This what if thinking helps you in ideation. So this is just one of the things. What helps is how that problem is solved in the nature. Many solutions. For example, birds fly. insect flies, cheetah runs, gallops, the horse gallops. These are all natural things. They are things. They are animals. They have bodies. They have energy. They also work. So in robotics, a lot of ideas have been borrowed from the nature. So you can create ideas by observing the nature. Many times, when you are trying to find a solution, you are not the first one to attack that problem. For example, the problem of irrigation was solved by construction of dams by somebody sometime. Then others observed, and then they 1 minute. I think I need to solve this problem of water going reverse. 1 minute. Give me some time. 1 minute, 1 minute. I have to clean the outlet because that outlet is choked and the water which he has released from the terrace has fallen in balcony, and then it is going to fill up the balcony because the entire water on the terrace is coming down now. So look at this now. I have to solve this problem. There's a lot of water coming, and this water is going like this. Okay, give me a minute. I will just come back. So the outlet was choked up, which I released. The water is now flowing. Okay. So coming back to the observation of the solutions made by others. So you can copy somebody and then use that direct solution by copying it. Copying a solution is a very natural process. Everybody does that. Monkeys are copied by human beings. Children copy adults. Say, developing Japan, the Emperor of Japan decided in 1860 to develop the country economically and technologically, and they decided to copy. They decided to learn from Germans, from Europeans, from British. They went there, they learned, they brought the ideas, they brought things, and they try to reproduce them. And they developed technology in a systematic way. Within 100 years, Japan became quite powerful. Not even 100, just about from 1860 to 1940s. Japan became so strong that they even got ambitious to rule the rest of the world, and they attacked China, and then there was a Second World War also. So it is a power that we get by solving problems and creating solutions, and that power gives you ability. Okay, so copying is to be encouraged. Now we are normally associating copying with copying of the problems in the exam. That is considered, that is definitely bad, because when you are learning and you are being tested to check how much you have learned, at that time copying somebody else is bad, is wrong, it is illegal. But at the rest of the times when you're solving a problem, you should in fact learn from others and the other solutions. We should encourage that. The process of reverse engineering should be encouraged. Now, there are things that are not allowed by law. For example, if somebody has created a design and he has declared that it is my property, intellectual property, then just like if I build a home and this is my home, it is my property. So you can't enter and use it as your home. So this is the idea of the property. My house, my farm, my pencil, my eraser. So properties are recognized by the legal rights, and it is illegal to copy at that time and then make a business on that. But it is not illegal to study for the sake of learning. You are always allowed to open up the things, break down, see how they work, and then develop the model in your mind of that solution, and then improve on that to go further. Because as I said, only those solutions which are better, cheaper, and quicker, they get accepted compared to the old ones. And that is how the continuous evolution of the solutions happens and the ideas keep flowing. I'll just take a small break now and want you to ask questions or tell me, have you understood this basic theme that we are talking about? Any feedback? Sir, can you please tell me if whatever I told so far is clear, understood?
Yeah. It is clear. It is clear, sir. So it is totally clear, sir. No issue.
So what are the three things that make ideation? One is observation and experiments, which generates a knowledge. Second is identifying some problem, something that you want to change to make it better, faster, cheaper. Okay, this is a desire. This is the knowledge. Then you apply that, and then while applying and for solution, what do? You observe other solutions. You observe solutions by nature. You observe solutions by others, and you also try experiments based on your knowledge, and then learn from that experiment. Why? You have to try, because only when you convert your knowledge into some experiment, you can observe. So our observation and brain both have to work together to make the thing in reality. Otherwise, it remains only ideas. हाँ? मुंगेरी लाल के हसीन सपने हो जाते फिर वो जस्ट दिमाग में रखा हुआ है. जो कुछ दिमाग में है, whatever is there in your mind, you have to convert it into an experiment, convert it into a reality. When you create something out of your thinking, it becomes concrete. It becomes like an object. And then when it is an object, you can observe it. You can see it. You can understand it. And then you can see whether it is good or bad. If it is improved, you retain and make it still better. If it is not good, then you reject that. So this process of idea, experiment, observation, reject. Idea, experiment, creation, observation, accept. And step by step, if you keep on doing it, then you can reach a target. Steve Jobs wanted to make the best telephone, which everybody would just love to buy. He wanted to create an object which will be creating such a desire in everybody's mind that it will be, it will attract everybody, and then everybody will want to have it. And he succeeded. He succeeded in creating an object based on the telecommunications, mobile phone. But each and every aspect of that phone, he was very particularly insisting, and he in fact was ruthless. He was rude, but he was trying to make people work to make that thing Apple had many other products, but then he created focus on that iPhone, and then that iPhone was a big winner. Mac was another one, but iPhone and Mac, these two were objects which were created to be so attractive that people, all the people in the world want to buy it. And that process you have observed in many, many things. Many good branded products that you see, which you want to buy, are created with that intention. So observe these, learn from them. What are the processes which created them? Then you will understand. So continuous thinking and action to make things better, 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 and so on, results into solution, results into a desired solution. So, in fact, I was curious once, I was in Japan at that time, I was curious to understand how Japanese engineers or designers or people think to improve the design and how they come out with very nice designs. And I was asking this question to many people. One person gave me a very interesting answer. He said, Ashok, you really want to understand it? I said, yeah, really. In fact, I want to. We had gone to stay in his house. We met him in a museum where we were looking at old Japanese houses. And there, this family people, they said, we have a similar house. And then I didn't know him, but I was curious and I said, look, can I come to your house? And he said, okay, most welcome, come. So, see, this also shows one more thing. When you are learning, when you are observing, when you want to learn from more people, you must learn to communicate. You should not restrict yourself. How will I ask him? I don't know him. He's a stranger. Don't have that feeling. Feel free to communicate, to ask, to tell. So if somebody asks you, you tell. And if you want to know, ask. So asking and telling is a process by which we all learn from each other. I use that. So I use that. And you know what he told me? He said, Ashok, you do one thing. You clean anything, let's say window. Okay? And clean it again. And every day keep on cleaning it. Now, you can think about it and you can also imagine what would happen if you decide to clean, let us say, a floor in your room. As you go on cleaning, after first day, again you are cleaning, you will see something finer which was left behind. Then third day, again you clean. First of all, some dirt which is accumulated, that will get cleaned. But if you keep on cleaning, what happens? There is no end to it. You can make it still better, still cleaner. Even small defect you will start noticing, then you will correct them. And this is a process that child learns in Japan. Especially when they become professional, they follow that and then they apply it. That is why many Japanese good products like Sony's or Honda's, they have come out. So they copied technology to make a quantum jump. What happened in European Renaissance in terms of explosion of knowledge, explosion of interaction, creative interaction of scientist and engineer, that did not happen in the Eastern sector or happened in a limited extent because our Eastern societies were mostly focused on internal. So Buddhism or our philosophy, India, and all the Eastern philosophies, they were making human beings go inwards, think, understand, learn, and then that was a method of learning about the rest of the world. Materialistic learning was not very common. It was only a part of artisans or artists, mostly craftsmen, who were working with things. Many thinkers were not working with things. They were thinking and working only with ideas. So that is why a lot of art and philosophy got developed in our Eastern culture. But the Western culture developed in the direction of material. And then with the materialistic creativity, they produced. And Japan copied that. Japan took that and improved on that further. The process of improvement is Japanese. So what happened? The time came when I remember in 79, we started selling Japanese machine tools in India, and I went to Japan. At that time, Indians were thinking that the machine tools, best machine tools are German or American. Nobody thought that Japanese machine tools are good enough, because Japanese products were at one time considered to be unreliable. Today, the way we talk about Chinese products, exactly in the same way, people used to talk about Japanese products. They break, they don't work long. And that was the image. Even in India, it was not considered as a best product. But then in 79, when we got the machines and then we installed them in Hindustan Aeronautical, a couple of companies, and when people observed that, look, these machines are better and they're also cheaper and they're more efficient. So all the three qualities were there. And then rest is history. People started buying Japanese machines. Best machine if you want, go for Japan. And then the China has come. China has focused very much on cheaper. They are also now moving on to better and faster. But to make things better and faster requires more of a knowledge. Making things cheaper only requires acceptance of low cost. So low cost labor, large volumes, these are the ways of reducing the cost. So substitute by a cheaper material. So when you make a duplicate and do it with a cheaper material, it is cheaper. It may not be better. But there might be a large market for things which may not be better but are cheaper. In India, for example, a lot of people buy things which may not work very long, but at least they can afford to buy. If it is expensive, they can't even afford to buy it. So a lot of us accept little bad quality, but cheaper, because we can enhance our experience. It satisfies some demand, some need. So we go ahead with it. So China has encashed on that. Now, we have to understand as engineers that in our ideation, all the three things are important: cheaper, better, faster. Okay. And then we apply our knowledge and we keep increasing our knowledge. But how do we apply a knowledge? We apply by two methods. We apply the knowledge to create an idea, and we apply the knowledge to test our idea by implementing that idea and observing the behavior and then rejecting. In fact, when we solve a problem in exam or your mathematics problem or engineering problem on paper, what are you doing? You are applying some formula, you are coming out with some answer, and then when you check back and you realize that you have made a mistake, that is not a correct answer. What do? You reject that. Then you think of some other solution. So the idea in making you solve problems is the same one. Even if it is a paper problem, it's a hypothetical problem. It is a model of the reality, and you have to solve it. You have to create answer for the problem given to you. And that is a process which is going to make you capable of problem solving capability to be brought into you, to apply it in the reality also, to handle real problems. Now, let us look at this aspect of model. For example, in the early childhood, in our primary school itself, we learn Kala Kam Veg, the work, speed, and time problems. Those problems are, if one person takes 2 days to complete one task, 2 persons will take how much time to complete 3 tasks, like that. So what we are doing, we are converting our physical problem into a word level description or a model of the problem. So we have entities in our mind that okay, persons are resources. One person, one work takes 2 hours. 2 persons will take 2 hours for the same work. But if 2 people work together, then maybe it will be finished in 1 hour, because half will be done by one person, half will be done by other person. But if there are 3 such items, then it will require 3 times, because if one work takes 1 hour, 2 works takes 2 hours. So we are applying our understanding of relationship, a linear relationship between people, work, and speed, the speed and time and people. Okay. So this is what we have learned in childhood then, is to make a model of the reality. And we continue doing that. When we draw a diagram now of a beam or a circuit is a model. Circuit is not real. It is a model of things like resistor, capacitor, voltage source, current source, inductor. So these are electrical devices or objects, and we are creating a model. And then we raise question. In reality, the question for Edison was, how much voltage do I apply to get how much heat in that resistor, so that the temperature will rise to so much so that it will become white hot. It will become, it will start emitting the light. You can take this problem, if you know about the problem Edison tried to solve, you can also solve it. And this is something that is given at the end of chapter in every textbook. And therefore, the more you solve problems, the more capable you will become for solving the problem. Because, it's like riyaz, it's like habit. It becomes your habit. You take a problem and solve it. Take a problem, solve it. How do you know it's a correct solution? How do you know, by the way, in mathematics or in any, you always apply a check. You can trace back and say, oh, did I make any mistake? So what mistakes can you do? You can make mistake in seeing things wrong. Say, for example, there is a classic example of recognizing a rope as a snake. And then you think it is a snake and you will try to kill it. Are you trying to solve a problem? You're trying to solve a problem because you perceived it as a snake and you have to kill it because it is going to bite you otherwise. It's coming to you. You think it is going to attack you. So there's a fear. And then you're trying to solve the problem. But you made a mistake. You made a wrong observation. The light was not enough and there was only a rope lying on the floor and you thought it is a snake. So this is a mistake. So you can understand what is a when you make a mistake. If you don't understand when you make a mistake, then what happens? You get carried with that mistake and you will keep on convincing the rest of the world. No, it is a snake. It is a snake. But when will you see it? When the light falls on it, you will see it in a different way. So making a light fall on things is a way to see it in correct sense. You see what I mean? It is not just the physical light. If there is a thing which you are not understanding, then there are things which can throw light on it. Like, for example, if corona is increasing and we don't understand it, what is it that makes it more clear? Measurements make things clear. If you measure it, so you observe in the village, one person came from outside, he had corona, and then he contacted these 3 people, and then 3 people got corona. These 3 contacted 5 each, so then 15 people got corona, and then you can observe. So how do you learn this? By measurement. Like you test and find out whether there is a corona in a person or not. So the whole mankind went on doing it. And this is the process of problem solving that the whole mankind is applying through WHO, through every country, developing vaccines, developing things which will create resistance, immunity. And we are still not near the final solution because our problem also is changing. Today it is this, then it is Delta, now it is Omicron. So these are the problems. These are real problems. When the virus is in the lungs, the breathing becomes problem, and then there is a need of supplying more oxygen than what he can draw. Then there is need to measure the oxygen. There is need to find out how to push the oxygen. You try to push the oxygen, and if it is not synchronous with the breathing, then what will happen? Same thing with what happens when somebody chokes up your nose. When you try to take in, it is stopping. When you want to exhale, it is trying to push. So ventilators have to be designed to solve that problem, to push the air at the right time, allow it to go out at the right time, mix it with the right amount of oxygen, control it so that it doesn't push it so much that like a balloon in the lungs, the lung can burst with like a balloon. So there are problems of health, there are problems of infections, there are problems of many, many things. There are problems of water, there are problems of food. The economic problems are large. There is no work for the manpower to do. There is no job which will give them some money in return. Farmers have problem like today in Nagpur area, there is hailstorm, and the crop which was ready is just going away with the nature, with the plants are lying flat. There's a big loss. So how to solve that problem? In sometimes the crops don't have water. How to solve that problem? People want to learn, but they don't have money to buy the book. How to solve that problem? They want to learn, but they can't get into a school because it requires fees and admission. How to solve that problem? I'm hungry, but my teeth are aching and I can't bite. How to solve that problem? I want to see, but my eye vision has become bad. It is defocused. Something is wrong. How to solve that problem? So what happened? The solution of spectacles came, and there is a spectacle. Now I can see it. Spectacle was created. It is a solution created to improve the sight. If it degenerates, it requires study, it requires experiment, it requires establishing a proper methodology of making the solution which is cheap, good, and fast. Why fast? Because you have to make so many of them. And if you make a thing like say footwear, chappal, if you make it in such a way that you can make one shoe in 1 year, then only king can afford to have that shoe. Common people will be without the shoes. So if Bata develops machines to manufacture shoes at rapid rate, and then they make one shoe every few seconds, then they can give the shoes to billions of people. That is the meaning of faster. If you can cook, say, every 5-6 hours, people have to eat. But if you can cook only one meal in 12 hours, then can you feed? You can't. You can't feed everybody because you don't have enough resources to cook for so many. So you have to do it at the right speed, faster, better, and cheaper. Okay? We'll take a small break. Can you ask some questions?
Participants, I request you, if you have any questions, please just
No, I
raise
will
your
ask one
hand.
thing. No, I will ask one question. Everybody take the paper and pencil or pen and write down 5 problems that you can understand and see as the important problems. They may be your problem, your family's problem, your neighborhood problem, social problem, national problem. But try to take a problem which is near you. You can see it, you can measure it, you can analyze it, you can find solutions, you can test them out. The problem may be simple, like, for example, the water was getting locked in the balcony where we were talking just a couple of minutes before. And I have solved it at that time. Okay. Because I could see the process, the water was falling, but it was not going away. So it was getting accumulated. And with the previous experience, we have experienced this many times, that the drain hole becomes choked with the kachra and not cleaned. And so water cannot flow through it. So I had to clean it. Now for cleaning the hole, I required some stick or something which I can insert in that hole. So I went out, I had seen a stick at home at the back somewhere in the morning. So I remembered it. I was using that knowledge, brought that stick and I pushed it. Even though the water was falling, I became wet, but I pushed it and then the problem got solved. This we do keep on doing it for many, many things. So think of problems, write them down. Okay. You have 3 minutes. It is 10:52 in my watch. At 10:55, I want randomly some people to share. Okay, I'm going to give you more time.